TCL Book 14 Go is an ARM-based laptop that features a Qualcomm Snapdragon 7C chip. Full stats are not present on the screen. I decided to purchase it as one of the first fully supported and available Windows on ARM devices in my region. Therefore, you might be interested in it, especially if you're looking for a budget laptop with long battery life and 4G connectivity. This review aims to demystify some aspects of this model due to scarce documentation online and conflicting claims even on the manufacturer's site, mostly due to the 4GB RAM version being more common. This one features 8 gigs of RAM and a full HD IPS matrix, unlike the other, even cheaper model. The price is roughly $430 and in this you get a solid notebook experience. To demonstrate the key aspects of how this computer acts, I made up a few demos, so let's take a look. This one is the YouTube demo, absolutely how YouTube works, and spoiler, it's going to work absolutely alright. Barely any skipped frames, which of course are not visible, but can theoretically happen. Here are some statistics. And this video is running at 1080p. In minimized mode. In bigger mode it would be pretty much the same. So as you can see, this is absolutely decent. As the secondary demo, I wanted to demonstrate how Google search engine looks and works on this machine. And as you can see, it may be a bit slow, but that's because I'm recording this right now. Usually it's even snappier, but generally the experience is pretty much what you'd expect. And now finally, a user website. The image loading is absolutely alright. JavaScript is fully supported. The native browser is Edge, which is optimized for the architecture, although you can also install Firefox, available for the same architecture. Other browsers are totally possible, but may be a little slower. Therefore, Edge is the recommended browser for this computer. Now we're going to test two different applications with the same source code. However, one is being run natively and the other is run through a layer of emulation. If an application is written natively, then there's no emulation settings. This one on the right is emulated. Therefore, the settings are present. You can change them, though I don't recommend doing that. Everything works perfectly out of the box. And so let's launch the emulated version. As a Python application, it doesn't launch very fast. And here's a full HD picture captured in a video game. We're going to use it as a reference and a benchmark for how well the application responds. Here's how a selection responds. It's not very fast, but this is true even without emulation. So let's crop this image and then change the brightness and contrast. The previews are available in real time. So the x64 application seems to be responsive enough. Now let's try out the ARM native application. The big difference between them is that the one on the right uses Python 3.10, which is only available for x64, at least on Windows. The one on the left, though, is using Python 3.11, which is the first Python to support Windows on ARM. Okay, so let's try resizing this one. Maybe it is a little faster, but the response barrier is just... Maybe I make this up. So we can turn on the coordinates. They're going to be displayed and updated very fast. So cropping and doing the same things as in the previous example. It's almost identical despite these being made for completely different architectures. Therefore, if you don't have a program created natively for Windows on ARM, it's not a big deal, although you should expect worse performance than it would have been if it were compiled for Windows on ARM. In this next example, I decided to demonstrate Microsoft Excel as part of Microsoft Office. One of the key applications, and I'm opening a particularly big CSV file. Even though it doesn't respond very well, keep in mind that this is a gigantic CSV table. It's not optimized for Excel, but the entire program and the set of Microsoft Office applications is available for ARM64. Therefore, it's going to perform absolutely the same as it would be for x86. That would not be true on Linux, where Microsoft Office is unavailable. The best next thing you have is OpenOffice and LibreOffice. However, if you're used to Microsoft Office, it's fully available here. And finally, I wrote a short script for Fibonacci number sequence and decided to test it out on two different Pythons, one being ARM native, that runs in about 5 seconds to display the number, and then Python emulated that's intended for AMD and Intel chips. The performance here is quite different. It's actually 2 times as big, and that doesn't account for the start of the program. And so here's the ARM version of Python, and here's the AMD Intel version. So to wrap this up, I'd like to say that this is a very solid choice if you're seeking for a simple netbook type device. It barely heats, consumes about 6 watts, of which 5 are dedicated to its CPU. While it is not the most powerful machine, and it's questionable whether a programmer or developer would consider this, however, I ran into times where 4G connectivity became really handy. So if you would like to get the minimal hardware for maybe web browsing, office work, and other non-intensive tasks, then this would be the perfect choice. Perhaps this was the original vision for notebooks if processor architectures were not a big limitation.